72 hours ago, the European Space Agency released what they called the clearest images yet of 3I Atlas, the interstellar object that's been haunting our solar system for months. Billions of dollars in optics, 7 orbiters aligned for one perfect shot. And what did we get? A blur, a white smudge that could be anything, dust on the lens, digital noise, a trick of exposure. But the timing of that release and what followed has everyone asking the same question. Because NASA's official channels went silent at the exact same moment those images dropped. China's Tianwen-1 orbiter, silent. The UAE's Hope probe, silent. Every agency with eyes on the same object, all quiet, all at once. According to Harvard astrophysicist Avi Loeb, what we're looking at might not even be natural. The spectral readings show industrial-grade nickel without iron, a combination that doesn't occur in nature, 33 billion tons of chemistry that breaks every rule. And here's the part no one's talking about. In less than a week, 3I Atlas will pass behind the sun, invisible to every telescope on Earth for more than a month. The perfect blackout, the perfect time to change. So before that happens, before this thing vanishes where no one can see it, let's talk about the theory that's been spreading quietly across observatories, encrypted servers, and back-channel forums. What if this isn't just another interstellar visitor? What if every new image, every missing pixel is part of a pattern that's growing, and we're running out of time to see the truth? If you're listening to this right now, hit that like button, subscribe for the next transmission, and tell me where you're tuning in from. Because the silence around 3I Atlas might be about to end. Chapter 1. The Release that broke the internet. October 7th, 2025, will be remembered as the night the internet collectively lost its patience with science. For weeks, the buildup had been relentless. ESA had promised the closest, clearest images ever captured of 3I Atlas, humanity's third, confirmed interstellar visitor. A dozen press releases, 2 teaser statements, and 1 countdown streamed live across their official channels. When the feed went live, 500,000 people tuned in. The opening frame was pure theater, the ESA logo fading into a deep black sky, a white caption reading, "Closest approach, October 3rd. And then, the image appeared, a single white dot. No tail, no structure, no definition, just a pale blur drifting across a star field. Within seconds, the comments exploded. Is that it? That's the best they've got? We waited months for a snowflake? By the end of the broadcast, the hashtag #WhereIsAtlas was trending in 11 countries. Amateur astronomers started posting side-by-side comparisons, their own crisp, detailed photos of ordinary comets shot from backyards using consumer cameras versus ESA's multi-million-dollar capture. The difference was embarrassing. And then came the anger. Within hours, major space commentary accounts on X and Reddit lit up with outrage. One post from AstroTruths read, "Billions in funding, 7 orbiters, and the result looks like someone sneezed on a lens." Another, from Astronomy Vibes, simply captioned a blurred ESA image with, "Weather balloon in a foggy backyard." It wasn't just mockery, it was disbelief. People felt cheated. The European Space Agency had spent years cultivating an image of transparency, of bringing cosmic wonders closer to the public. But this felt like obfuscation, a performance meant to distract rather than reveal. The official press conference didn't help. When asked about the low quality, Nick Thomas, principal investigator for the CAS's camera aboard the ExoMars Trace Gas Orbiter, called the observation a challenge beyond the instrument's design. He explained patiently that the orbiter's camera was built to photograph the bright surface of Mars from a few hundred kilometers away, not a faint, fast-moving object tens of millions of kilometers distant. At that range, each pixel represented roughly 340 kilometers. The nucleus of 3I Atlas, estimated to be between 5 and 46 kilometers wide, would register as less than a single pixel. In other words, the blur was all they could possibly see. That should have ended the controversy. But it didn't, because Thomas also admitted something else. He said, We knew the resolution would be limited. The goal was to test tracking protocols, not deliver high-definition imagery. That sentence broke containment. If the goal wasn't to deliver detail, why frame the release as the clearest images yet? Why promote it as a visual breakthrough? Why stage a live event? By dawn, thousands of threads were dissecting every aspect of the announcement. The color balance, the metadata, the timestamps. Someone noticed that the file headers for the released photos listed different processing dates. Some as early as September 29th, others labeled October 4th. That discrepancy shouldn't exist. It implied multiple edit cycles, maybe even multiple image sources. Others zoomed in and claimed to find faint geometric patterns buried in the noise, rectangular grids, sharp lines where none should be. Image artifacts, perhaps, or evidence of something more deliberate. And yet, through it all, ESA maintained its silence. No clarifications, no follow-up, just a sterile statement. All available images have been released. That's when the comparison videos began spreading. A YouTuber named Dobsonian Power, known for his careful astrophotography tutorials, uploaded a 40-minute breakdown titled, "Why the ESA's Atlas image Doesn't Add Up." He overlaid the ESA blur with his own stacked exposures of Comet Lemon from 2 years earlier, shot with a mirrorless camera and a mid-range telescope. His images were crystal clear, showing the comet's coma, the tail structure, even faint jets of gas. Then he zoomed out, placed the ESA blur beside it, and asked, calmly, "How does a government agency with billion-dollar optics produce less data than a guy in his driveway?" The video hit 2 million views in a day. Other channels followed: Veritas Lens, Skywatch Archive, Deep Orbital Files, each one adding to the storm. Some accused ESA of incompetence, others whispered conspiracy, but a few noticed something subtler: the timing. ESA released their image at 02:17 UTC, exactly 3 minutes after NASA's communication servers went offline during a partial government shutdown. Coincidence, maybe. But if you've spent enough time following how information moves, or doesn't move, between space agencies, you know coincidences like that don't just happen. That's when the silence started to feel coordinated. Because while ESA was playing defense in press briefings, NASA was quiet. The United Arab Emirates Hope Orbiter, which had also been scheduled to capture images, didn't post a thing. China's Tianwen-1? Offline. 4 separate space agencies, 3 separate governments, all either silent or citing technical issues. No one wanted to say it out loud, but the theory began forming in comment sections and Discord groups. Maybe the blur wasn't the problem. Maybe it was the only thing they were allowed to show. For days, the debate raged. Mainstream science communicators urged caution, insisting that optical limitations are not evidence of conspiracy. But the public's patience was gone. Every unanswered question only fueled suspicion. Because the deeper people looked, the stranger it got. On the ESA's own data portal, someone noticed that image file number 6, part of the official series, had been quietly replaced 12 hours after release. The original, archived by independent researchers, showed a slightly brighter pixel cluster along the object's lower edge. The new version didn't. The pixel values were identical everywhere else, only that tiny bright region had vanished. When asked, ESA said it was a correction for a calibration artifact. But to a public already primed for distrust, it sounded like editing evidence. By the end of that week, the story had crossed into mainstream news. CNN ran a headline: "Public frustration over ESA's interstellar photos." The Guardian called it "the blur heard round the world." And somewhere between the outrage, the memes, and the technical analyses, the narrative shifted from curiosity to paranoia. People stopped asking, "Why is the image blurry?" and started asking, "What are they hiding?" It's a dangerous question, because once it's asked, there's no going back. Every silence becomes suspicious. Every delay becomes deliberate. But here's the detail no one seemed to notice. ESA never said the images were from October 3rd. They said captured during the period of closest approach. A small difference in phrasing. A massive difference in implication. Because if those frames weren't taken on the day of the flyby, if they were older, recycled, or stitched together from simulations, then the entire event wasn't an observation. It was theater, a pressure release valve, something to keep the public occupied while the real data stayed locked away. And when you start from that assumption, that we were shown something meaningless to distract from something meaningful, the next question becomes unavoidable. Why release it at all if they knew it would fail? Chapter 2. The missing data. The silence didn't just last hours, it stretched into days. By October 10th, every major space forum was buzzing with one question: where are the rest of the images? ESA had promised a multi-angle observation campaign with support from NASA's Mars Reconnaissance Orbiter, China's Tianwen-1, and the UAE's Hope probe. Each of those spacecraft was perfectly positioned for capture during 3I Atlas's closest approach to Mars, and yet only ESA had released anything, and their anything was a blur. At first, the explanation sounded almost reasonable. NASA's official feed posted a single statement: due to the U.S. government shutdown, public data updates are temporarily paused. No press briefings, no Q&A sessions, no follow-up. Shutdowns aren't unusual. They happen on average every few years when Congress can't pass a budget, but this one felt timed too perfectly. Out of more than 15,000 NASA employees, over 80% were furloughed. The agency's website froze, social media accounts went dark, and communication with external partners stalled. Only essential systems, like spacecraft telemetry, remained online, which meant that the Mars Reconnaissance Orbiter was still transmitting data. It just wasn't being shared. That detail alone sent conspiracy channels into overdrive. On Reddit, one post gained over 70,000 upvotes in a single night. NASA's cameras didn't stop working. They stopped talking. And then came the leaks. Someone claiming to be a NASA systems engineer posted a message on 4chan's X board. Data is still being received. The images exist. They're being reviewed internally for anomalies. Within hours, screenshots of that post spread across Telegram, Discord, and encrypted Twitter accounts. Most of them were quickly deleted. But once the idea was out there, that the silence wasn't accidental but deliberate, it couldn't be contained. Independent observers began analyzing transmission schedules from NASA's Deep Space Network. Normally, the DSN logs downlinks from spacecraft every few hours. Between October 3rd and 10th, something strange appeared. Regular signals from the Mars Reconnaissance Orbiter continued, but the packet sizes spiked sharply right after the Atlas flyby, then dropped to near zero 2 days later. In other words, massive amounts of data were transmitted, then nothing. When questioned, NASA's Public Affairs Office gave a short, almost dismissive reply. Telemetry and engineering data remain within expected parameters, which, of course, didn't answer the question. If the spacecraft was functioning normally, why no images? Why no processed releases? Why not even a confirmation that images existed? By mid-October, the Atlas blackout had turned into the biggest online mystery since the James Webb Deep Field glitch back in 2023. Forums filled with side-by-side comparisons of missing frame numbers, transmission gaps, and timestamp discrepancies. One YouTube analyst, who goes by the handle Spectral Parallax, claimed to have cross-referenced orbital positions with DSN ping data. His conclusion was simple but chilling. They were taking pictures, the images were real, but something in them triggered an internal lockout protocol. Lockout protocol. The phrase stuck. Soon every discussion was looping around that term. What would trigger NASA to withhold images? A classified object? A potential threat? Or something so unexplainable it needed contextual review? Mainstream media tried to calm things down. CNN's science correspondent quoted a NASA representative saying, "Data review procedures are standard after any unexpected event." But even that phrase, unexpected event, sounded loaded because no one had reported an event, at least not officially. Then, on October 12th, a strange file appeared on Pastebin. It claimed to be an internal communication from the Mars Reconnaissance Orbiter Operations Team. The message was brief. HRSC subsystem reports non-standard return. Imaging data inconsistent with optical model. Recommend hold release pending review by OSIRIS Coordination Panel. If genuine, that line was explosive. The HRSC high-resolution stereo camera isn't even part of the Mars Reconnaissance Orbiter. It's from ESA's Mars Express mission. Why would a NASA team mention an ESA instrument unless they were cross-referencing data? That implied coordination across agencies, and coordination requires communication. Which means ESA and NASA weren't as cut off as they claimed during the shutdown. The post was deleted within an hour, but screenshots survived. Over the next 24 hours, ESA quietly updated their Atlas data page. The new statement read, "Data review in collaboration with partner agencies is ongoing." Collaboration, not isolation. Suddenly, the shutdown excuse fell apart. Because if the US government was supposedly frozen, how was ESA collaborating with NASA? Journalists started asking those questions. None got answers. The European press office simply referred to international data integrity procedures. Meanwhile, in amateur circles, frustration turned into obsession. Astro enthusiasts built spreadsheets tracking every public satellite capable of imaging Atlas's position. Mars Express, Tianwen-1, Hope, Trace Gas Orbiter. Not a single agency had released a new image since October 3rd. The silence wasn't random. It was patterned. And that's when people started noticing something even stranger. Small inconsistencies in time. ESA's official timestamps for the released images showed exposure windows between 0212 and 0217 UTC on October 3rd. But an amateur astronomer in Portugal, using a synchronized atomic clock, recorded Atlas's light curve peaking 5 minutes later, at 0222 UTC. That's not supposed to happen. The brightness data didn't match the official timeline. In astrophysics, 5 minutes can mean the difference between alignment and misidentification. So either the amateurs were wrong, or the official data was shifted. And if it was shifted, then ESA's images might not even correspond to the actual flyby moment. They could have been older captures reprocessed to fill a gap. When I reached out to a retired NASA imaging technician, he didn't dismiss the theory. He just sighed and said, "Sometimes you have to feed the public something, even if it's noise." Noise. That word stuck with me. Because that's exactly what the ESA blur looked like. Noise with just enough form to keep people watching. By October 15th, the pattern of silence had become impossible to ignore. 4 independent agencies, 3 different governments, 1 shared object in space, 0 transparency. It wasn't a blackout. It was a choreography. And then came the first real slip. A small blog from an Italian observatory published a single-sentence update on their site. Spectroscopic data from Atlas returned unusual nickel-iron imbalance. Nickel without iron, the same impossible ratio rumored from earlier leaks. The post was deleted within 2 hours, but not before being archived. That's when the theory began to shift. The conversation wasn't just about missing photos anymore. It was about missing physics. If Atlas's emissions truly showed nickel without iron, something was fundamentally wrong with our understanding of how interstellar bodies form. Either it wasn't natural, or it wasn't alone. ESA went silent again. NASA didn't comment. And then, almost theatrically, China's Tianwen-1 mission announced scheduled maintenance on its imaging system. 3 agencies, 3 excuses, all in a row. At that point, the story stopped being a science debate. It became a cultural event. Live streamers stayed up all night dissecting each clue, each silence. Twitter threads turned into novels. People began mapping the timeline of events, overlaying them with unrelated phenomena, radio blackouts, magnetic fluctuations, satellite anomalies. And through it all, the question kept coming back, whispered at first, then shouted across feeds. What are we not being shown? No one wanted to say it out loud, but everyone felt it. Something was missing. Not just data, context, truth. The kind of silence that doesn't come from malfunction, but from intent. And if that's true, then what exactly were they seeing in those missing images? Chapter 3. The Amateur Evidence. While space agencies went dark, the amateurs refused to blink. They filled the silence with telescopes. From Portugal to Arizona, from backyard observatories to cheap rigs propped on apartment balconies, thousands of eyes turned toward a single patch of sky, the region where 3I Atlas had last been seen near Mars. The official channels said nothing, but the night sky said plenty. On October 10th, an astrophotographer from Lisbon, known online as Dobsonian Power, uploaded a single image to his small but devoted YouTube channel. The caption was short, almost timid. "What on earth is it?" The photo wasn't much at first glance. A speckled gray field, faint stars, a blur at the center. But when you zoomed in, the blur wasn't shapeless. It had edges, angles, something geometric that didn't belong. He'd captured the image using a solar telescope, the wrong tool entirely. Solar telescopes are built to observe the extreme brightness of the sun, not faint interstellar objects drifting millions of kilometers away. The filters distort light from deep space. The colors shift. Details warp. But even with those distortions, something about that shape didn't fit any known natural pattern. He didn't claim it was artificial. He didn't claim it was alien. He simply asked, "Why does it look like that?" Within 6 hours, the post exploded. Reddit threads, astronomy forums, Twitter reposts. The image spread faster than any official release. 2 camps immediately formed. The believers said it was proof, a fragment of metal, a structure, maybe even propulsion. The debunkers said it was pareidolia, the human brain imposing order on chaos. And both were right in their own way, because the more people processed the image, the stranger it became. Some users applied standard astrophotography stacking techniques, layering multiple frames to reduce noise and reveal fine detail. Others used AI enhancement tools like Gigapixel or StarNet to deblur and contrast the faint edges. The results varied wildly. Some enhancements showed nothing, just a slightly sharper blur. Others revealed what looked like parallel ridges, uniform spacing, symmetry. That's not supposed to happen in nature. Comets and asteroids are irregular, chaotic, asymmetrical. They don't have straight lines. The debate quickly shifted from "what is it" to "why are we the only ones seeing it?" A video by Luna Archive, an independent astronomy channel with a skeptical following, pointed out the timing of Dobsonian's observation. His timestamp matches the exact window NASA said was off-limits due to the shutdown, the host explained. That means his telescope caught Atlas at the same time official instruments were offline. So, if his data is real, then someone's lying about when those orbiters went dark. That single statement flipped the story from curiosity to confrontation. More amateurs joined the hunt. Across Europe, night after night, telescopes tracked the region near Mars. The collective effort became known as the Citizen Array, an informal network of volunteers pooling raw sky data on shared drives. They weren't professionals. They weren't funded. But together, they produced more usable images of Atlas in 2 weeks than any government agency had released in a month. And their findings didn't line up with the official story. A German observer using a standard 10-inch Newtonian telescope reported a brief flare, a sudden increase in brightness lasting less than 2 seconds. He described it as a glint, like sunlight off a polished surface. 2 nights later, a group in Chile recorded something similar, a pulse of reflected light, recurring every 21 minutes. Too regular for randomness. When they overlaid their timestamps, the pattern lined up almost perfectly. For astronomers, synchronization means structure. If light pulses repeat across separate observers on opposite sides of the world, it usually means a rotating object, something with a consistent shape reflecting sunlight at predictable intervals. But the calculated rotation period, 21 minutes, didn't fit any known cometary model. For an object that size, spinning that fast would tear it apart. So either the amateurs were wrong, or the physics was. Meanwhile, mainstream outlets dismissed the findings as algorithmic hallucinations, a polite way of saying, your computers are making it up. That explanation worked for a while, until someone cross-referenced the amateur images with old ESA calibration files. One of the users from the citizen array discovered that the faint geometric grid in the Dobsonian photo matched the pattern of a reflection artifact seen in an early test image from ESA's own Cassis camera, taken years earlier during a Mars calibration sequence. It was almost identical, but rotated. That meant either the amateur's enhancement had coincidentally recreated a known instrument artifact, or the artifact itself had been embedded in the image somehow, maybe even from the original ESA data stream, which raised a question no one wanted to consider. Were the amateurs actually seeing what ESA saw? Not by coincidence, but because they'd stumbled into the same data that had been cleaned from the official release. By mid-October, the Citizen Array had over 2,000 contributors. Their Discord server turned into a hive of data parsing, code sharing, and sleepless arguments. Someone uploaded an unverified CSV claiming to contain spectral values extracted from a suspected Atlas reflection. It showed spikes consistent with nickel gas emission, the same chemical impossibility that the 4chan leak had described days earlier. That was when the first coordinated takedowns began. Several Citizen Array videos vanished from YouTube overnight. Accounts were flagged for misleading scientific information. Links to their shared Google Drive folders went dead. Twitter posts containing the enhanced images were shadow banned or labeled synthetic media. No one knew who triggered it, and that, ironically, proved the amateur's point. When official institutions are silent and citizen evidence disappears, silence becomes confirmation. Dobsonian Power himself posted a quiet message before going offline. "I'm not claiming anything, but patterns don't censor themselves." It was his last public post. Since then, smaller observers have tried to replicate his results. Some succeeded partially, faint reflections, pulsing brightness, geometric shadows, but none achieved the same clarity as that first image. Skeptics say it's because his setup was flawed, that the solar filter created the illusion. Believers argue that he caught something fleeting, a moment when Atlas reflected sunlight directly toward Earth before slipping behind the sun's glare. Both sides agree on one thing. Whatever it was, it's gone now. But the echoes remain. Across social media, hashtags like our Atlas pattern and the nickel signal trended for days. Podcasts dissected the image pixel by pixel. Former NASA scientists were dragged into live streams to explain the statistical unlikelihood of simultaneous reflection anomalies. The more they explained, the less anyone believed them, because disbelief had become contagious. The story was no longer about a blurry dot. It was about trust, about who gets to decide what's real. And somewhere, buried under the noise, the original amateur image kept resurfacing, mirrored, compressed, distorted, passed from forum to forum like digital contraband. Each time it reappeared, someone would enhance it again, tweak the brightness, sharpen the contrast, and claim they saw something new. Sometimes it was a shape, sometimes it was a light, sometimes it was nothing at all. But every time, the feeling was the same, that we weren't supposed to be looking, that we'd glimpsed something meant to stay hidden. And if the amateurs were right, if those reflections weren't artifacts but signals, then the missing data wasn't missing by accident. It was erased, deliberately. And that realization changed everything. Because if the people with telescopes in their backyards could see what billion-dollar agencies wouldn't show us, then maybe, just maybe, the worst theory wasn't a theory anymore. It was evidence. Chapter 4. The Leak. It began, as most modern revelations do, with an anonymous post that should have vanished in minutes. On October 14th, at 0241 UTC, a user on 4chan's AX board uploaded a thread titled ESA Data Leak, Internal Anomalies on 3i Atlas. The post was text only, written in careful academic English. No memes, no sensational claims. Just a wall of text filled with numbers, spectroscopic ratios, and file paths that looked too specific to be invented. I am a doctoral researcher with temporary access to composite datasets shared between ESA and NASA, it began. This post will self-delete. I don't care if you believe me, but you should understand what they found. The message went on to list 3 observational anomalies. The first was labeled chemical impossibility. According to the Post, the spectroscopic analysis from the trace gas orbiter had detected a sustained nickel vapor emission rate of approximately 100 kilograms per second with negligible iron signature. In normal cosmic chemistry, that can't happen. Nickel and iron are twins, born together in the hearts of supernovae, fused in the same stellar crucibles, traveling side by side through interstellar space. You can't separate them. If nickel is there, iron is there. Always. Finding nickel without iron is like finding smoke without fire. It violates the atomic logic of the universe. The second anomaly was labeled thermal contradiction. At its closest approach, 3I Atlas was measured at a surface temperature of minus 160 degrees Celsius, cold enough to keep most ices solid. Yet it was emitting gas at a rate more consistent with temperatures twice that high. In short, it was venting like an engine while staying frozen solid. The third was reflective oscillation, a pattern of light variation inconsistent with rotation. The brightness wasn't changing in sync with spin, but in sync with something else, something periodic, deliberate. If you model the light curve using standard albedo variation, the Post said, you get noise. If you model it as a timed emission, a pulse, it fits perfectly. The user claimed the ESA team had flagged the data as non-natural behavior before the file was sealed for review. Within hours, the post went viral. Most people dismissed it as another hoax, but a handful of astrophysicists recognized the numbers. The spectroscopic values matched a known calibration profile used by ESA's Cassis camera, not public information. Whoever wrote that post had access to internal data. Then came the kicker. Attached at the bottom of the thread was a string of hexadecimal characters. Someone decoded it into text and found what looked like a timestamp and a directory name: TGO, OBS, Atlas, RAW, Locked, TER12, OCT, 2025. That wasn't speculation. That was the exact format used in ESA's internal file hierarchy. By the time moderators tried to delete the thread, it had been archived and mirrored across a dozen independent servers. The next morning, the leak hit mainstream social media. Headlines exploded. Anonymous insider claims ESA hiding interstellar data. Chemical impossibility detected in Comet Atlas. Nickel without iron, the cosmic contradiction. ESA's official response was as short as it was suspicious. We do not comment on unauthorized material or speculation. But silence is rarely neutral. It speaks louder than denial. Within 24 hours, several of the astrophysicists who had tweeted about the leak deleted their posts. Their accounts went private. One of them, a postdoc at Leiden University, quietly changed her bio to remove the line ESA Research Fellow. That same night, an update appeared on a small physics forum frequented by data scientists. A user called Orion Trace claimed to have verified part of the leak by comparing the ratios to archived cometary data. The spectral profile described is real, he wrote. I cross-checked against 10 years of comet emissions. Nothing matches. Not Halley, not Encke, not Borisov. It's chemically unique. He ended the post with a single line. If it's real, it's engineered. The phrase spread like a contagion. Engineered, not natural. Constructed. Meanwhile, ESA servers began experiencing unusual downtime. Their open data archive was intermittently unavailable. When it came back online, several Atlas-related files were gone, replaced with placeholders reading "Access temporarily suspended pending verification." Publicly, they called it maintenance. But internally, something was happening. A week later, a journalist from Der Spiegel claimed to have received an encrypted email from someone within ESA's data integrity team. The message was simple. You are looking in the wrong place. The real data isn't missing. It's misfiled. When the journalist pressed for clarification, the sender stopped replying. 3 days later, ESA issued a new press release with an oddly worded statement. Certain anomalous spectral observations are currently under collaborative review with partner institutions. It was the first public acknowledgement that anomalies existed at all. NASA, of course, said nothing. But while Europe deflected and America stayed quiet, The amateurs kept digging. Using open-source satellite telemetry, a small group of researchers traced irregular transmissions from ESA's deep space antenna in Malargui, Argentina. Every night between 010 and 030 UTC, the dish transmitted encrypted packets toward the red planet. The recipients were labeled TGO Task Lock. Whatever was being sent, it wasn't public. That's when the story stopped being about data and started being about control. Science thrives on replication, on transparency, peer review, and shared information. But every detail of the Atlas investigation was being pulled deeper into classified silence. The 4chan leak became a digital ghost story, a message in a bottle that slipped through before the locks engaged. And yet, for all its technical detail, one sentence from that anonymous post kept resurfacing, quoted across forums, podcasts, and comment sections. They are not trying to hide the images. They are trying to hide the context. At first, no one understood what that meant. But as more fragments surfaced, the nickel gas readings, the missing infrared data, the coordination between ESA and NASA during a supposed shutdown, the phrase began to make sense. Context wasn't about what they saw, it was about what it meant. If 3i Atlas was truly emitting industrial-grade metals, maintaining structural brightness, and pulsing light at intervals too regular for coincidence, then it wasn't behaving like an object at all. It was behaving like a signal, and signals have senders. That possibility, that this wasn't just a wandering rock, but something constructed, ancient, and perhaps still active, was too big for a press release, too dangerous for headlines. By October 20th, the thread had vanished from nearly every platform. Search results returned nothing but debunking articles and archived screenshots. Yet, every attempt to erase it only made it stronger, because information, like light, doesn't vanish when blocked. It scatters. And in those scattered fragments, a new theory began to crystallize, one darker than anyone had dared to say aloud. What if 3i Atlas wasn't discovered by accident? What if it was found because it wanted to be? Chapter 5. The disturbing calculation. When it comes to deep space, math doesn't lie. It's supposed to be the one constant truth, the firewall against imagination. Numbers don't care about belief, but sometimes they care too much about what they reveal. The first sign that something was wrong came from a spreadsheet, one that wasn't supposed to exist. In late October, a set of orbital data labeled Atlas Rel Phase JART Model V5 began circulating among independent astronomers. No one knew who uploaded it. The metadata pointed to a private academic repository in Switzerland. The document contained hundreds of rows, position vectors, velocity components, and phase angles for 3i Atlas recorded between September 29th and October 15th. At first glance, it looked like any other ephemeris table, but the numbers didn't line up. When plotted, the trajectory didn't follow a smooth hyperbolic arc, the natural path of an interstellar visitor passing through the solar system. Instead, it showed micro-deviations, minute shifts in velocity that seemed to occur in bursts, as if the object were applying tiny corrections to its own path. One observer on Reddit put it simply: it's steering. Of course, that's impossible. Interstellar objects don't steer. They drift. They tumble through gravity wells, indifferent to destination or design. Unless an anonymous group calling themselves Project Vector decided to test the data. Using standard dynamical models, they simulated Atlas's motion with and without those velocity shifts. The difference was staggering. The uncorrected model predicted a closest approach to Mars on October 3rd at 0302 UTC. The observed light curve, verified by ESA and independent amateurs, indicated the pass occurred at 0222 UTC, a 40-minute discrepancy. For an object traveling nearly 110,000 kilometers per hour, that's a spatial difference of more than 70,000 kilometers. In cosmic terms, that's a direct course correction. Someone, or something, changed its trajectory. NASA's official orbital solution still listed the object as ballistic. But when one member of Project Vector submitted a query to JPL's Horizon system, the response came back with an unfamiliar tag: Data under revision, non-gravitational model pending. That single phrase, non-gravitational model, set the internet on fire. Within hours, threads on X, Reddit, and astronomy Discord servers were filled with screenshots of the Horizons message. Some users thought it referred to outgassing, the process by which jets of vapor from a comet's surface can subtly alter its path. But others noticed that the correction factor was too consistent. Outgassing produces random, uneven thrust. Atlas's deviations were precise, directional, and periodic. Every 6 hours, the object seemed to accelerate by a fraction of a meter per second, always in the same vector alignment relative to the Sun. That's not random. That's design. A physics professor from Caltech, speaking off the record, described it bluntly. If those numbers hold, we're not looking at an inert rock, we're looking at an active object compensating for solar gravity. But the real shock came when someone calculated the energy required. Even assuming a mass of 10 trillion kilograms, conservative for a comet of its size, those microaccelerations would require energy outputs on the order of several gigawatts, equivalent to a nuclear reactor. Yet no corresponding heat signature was detected. The object remained cold, dark, silent. ESA's infrared sensors saw nothing. NASA's instruments, the ones still supposedly offline, recorded no thermal flare. So where was the energy coming from? That question birthed what online communities soon dubbed the disturbing calculation, a viral post that tried to reconcile the impossible physics with the available data. The post began with a line that felt like a confession. We tried to balance the equations. They don't balance. Either our physics is wrong or the object isn't obeying it. It then broke down 3 possible explanations. 1. Unseen propulsion. If Atlas was emitting a form of thrust invisible in the infrared spectrum, perhaps through electromagnetic or quantum means, it could maneuver without detectable exhaust. But that would imply technology beyond human capability. 2. External manipulation. Some theorize that the object was being guided remotely by gravitational or electromagnetic fields, as if responding to signals. The same signals amateur radio operators claimed to detect weeks earlier in the nickel frequency band. 3. Information-based motion. The wildest theory of all proposed that Atlas wasn't a spacecraft at all, but a kind of information object, a self-correcting system that maintains position through feedback with surrounding space-time. A mathematical construct made real. That last one sounded insane. But then again, so did the data. In one corner of the internet, an astrophysicist known as Dr. Mirko Valen, who had previously published papers on plasma propulsion, uploaded a 3-minute clip titled "Atlas Moves Wrong." He plotted the acceleration spikes against solar wind intensity and found no correlation. Then he did something that made everyone stop scrolling. He inverted the data. When he flipped the time sequence, the acceleration pattern matched the cadence of radio interference recorded by amateur operators during the same week. Every time the signal pulsed, Atlas shifted course, slightly but measurably. Dr. Valen stared into the camera and said one sentence before ending the video. Something is talking to it. The clip was deleted within 24 hours, but not before it was mirrored across dozens of channels. Meanwhile, official agencies doubled down on silence. ESA issued a statement denying any verified anomalies in the orbital solution. NASA's Jet Propulsion Laboratory stopped responding to requests entirely, but the numbers didn't stop existing. Project Vector released a follow-up showing that when you extrapolate Atlas's new trajectory forward past its perihelion, its closest point to the Sun, it no longer exits the solar system cleanly. Instead, it bends. Not back toward Mars, not toward Jupiter, but toward Earth's orbital plane. The correction was slight, less than half a degree, but enough to shift its outbound path dangerously close to our neighborhood by early December. At first, no one wanted to believe it. But then, the Minor Planet Center quietly updated its tracking parameters. The official press release described it as an adjustment to account for observational uncertainties. Uncertainties. That word again. By now, every major observatory on Earth was trying to get a fresh look at the object before it disappeared behind the sun, but no one could agree on where exactly to point. The coordinates kept drifting. Just a little, just enough to stay elusive. It was as if the object didn't want to be seen. That's when the final part of the disturbing calculation emerged. A group of data scientists, working independently, discovered that if you model Atlas's motion not as a comet but as a receiver, something maintaining a constant distance relative to multiple reference points, the numbers make perfect sense. Its velocity changes weren't random at all. They were triangulated. Atlas wasn't being pulled by gravity. It was synchronizing. To what? No one could say. But the implication was clear. 3i Atlas wasn't drifting through space. It was aligning with it. By the time November began, even skeptics were starting to whisper. Because physics can be stretched, but it can't be rewritten without consequence. And if an interstellar object is rewriting it in real time, bending the rules of motion, temperature, and energy, then it isn't just a discovery. It's a message, a statement written in the language of the universe itself. I am not a mistake. I am intentional. And the worst part? The math agrees. Chapter 6. The Historical Echo. Every mystery in space eventually echoes. Some are faint, ripples fading into background radiation. Others come back louder each time, as if the universe keeps repeating a message we refuse to hear. 3i Atlas wasn't the first time our instruments stumbled upon something that didn't fit the math. We've seen it before, and every time we buried it under new labels. Anomaly, artifact, statistical noise. In 1977, a technician named Jerry Eman was scanning data from the Big Ear radio telescope at Ohio State University when he saw a signal spike so clean, so narrowband, that it froze him in place. It lasted 72 seconds. He circled the data in red pen and wrote a single word in the margin. Wow. No one ever found the source. It didn't repeat. It wasn't a satellite. It wasn't Earth-based interference. It came from somewhere in the constellation Sagittarius. From nowhere, really. The frequency was almost exactly the hydrogen line. 1420 megahertz, the universal broadcast channel of the cosmos. For decades, astronomers chased that signal. They built larger telescopes, finer filters, new software, and found nothing. But the echo never went away. Now, nearly half a century later, Atlas is repeating the same story, but louder, closer, and visible. Because when you overlay the incoming trajectory of 3i Atlas with the original vector of the WOW signal, they intersect, not perfectly, but within the same celestial corridor. A line stretching from interstellar space near Lyra, cutting across the solar plane, and now through our backyard. Coincidence? Maybe. But coincidences in astronomy tend to mean we missed something. Harvard astrophysicist Avi Loeb once called Oumuamua, our first known interstellar visitor, a messenger from another civilization. At the time, it sounded provocative, a soundbite designed to stir funding and outrage. But Loeb wasn't speculating. He was calculating. In 2017, Oumuamua entered our solar system moving faster than any comet ever recorded, then accelerated as it left. No visible jets, no outgassing, no explanation. It tumbled strangely, reflected sunlight irregularly, and defied every model of natural motion. Sound familiar? Now Atlas was doing the same thing, only more precisely. When astronomers compared the two trajectories, they found a chilling symmetry. Both objects entered from nearly the same galactic latitude, separated by less than 6 degrees. Both showed signs of non-gravitational acceleration. Both exhibited reflectivity inconsistent with ice and dust. But here's the part most people missed. Between Oumuamua in 2017 and Atlas in 2025, there were two other candidates, C 2019 Q4 Borisov and an object cataloged briefly as 2i Kamiya. Each one followed a similar inbound vector but at different inclinations, as if tracing the edges of an invisible spiral. When plotted on a three-dimensional map, those four trajectories, Oumuamua, Borisov, Kamiya, and Atlas, form a pattern. Not random, not scattered, but sequential. Each pass slightly closer to the inner solar system than the last, like a signal tightening focus. A mathematician from the European Southern Observatory ran the numbers. If the pattern continues, the next object in the sequence would intersect Earth's orbital plane within 2 decades. He called the formation the spiral return. His paper was quietly withdrawn 2 weeks later. That's the thing about cosmic echoes. They only get heard when they're inconvenient. When I started digging into old archives, I found something strange. A classified memo from NASA's Planetary Defense Coordination Office dated March 2023. It referenced a potential recurrence of non-gravitational visitors. The document cited internal research linking multiple interstellar objects to a shared point of origin in the Hercules-Lyra region, the same general direction as the WOW signal. The file was labeled provisional, not for public release. If that was genuine, then someone at NASA had already suspected the pattern years before Atlas appeared. And if they suspected it, maybe they prepared for it. In one of his last blog posts before the shutdown, Loeb wrote, "We are witnessing the beginning of a new class of interstellar object, one that may not be passive. The question is not whether it's natural, but whether we'll recognize intelligence when it's staring back through the telescope." That line hit differently after October, because what if we've already recognized it? What if the silence isn't ignorance, but caution? The more you trace the data, the more the pattern looks deliberate. Oumuamua was reconnaissance, Borisov was calibration, Kamiya was alignment, and Atlas is the approach. The timeline fits eerily well. Each object arrived roughly 2 to 4 years apart, each one closer, each one carrying a slightly different composition signature. If you treat them as random, it's meaningless. If you treat them as iterative, it's design. One independent astronomer, Dr. Celine Whittaker from the University of Cambridge, published a paper on this before her faculty email went dark. Her conclusion was radical but elegantly simple. The sequence behaves like a scan. A scan, as in a mapping procedure. Not invasion, not observation, but cataloging. She pointed out that the orbital inclinations of each visitor roughly correspond to the latitudinal distribution of Earth's deep space radar arrays. In plain terms, each time one of these objects passes through the solar system, it does so at an angle that maximizes exposure to our own sensors. It's as if something out there is testing our detection range. And Atlas might be the final calibration. If that's true, then the recent nickel gas readings and thermal contradictions aren't just anomalies, they're signatures. Identification codes written in elements instead of numbers. Nickel without iron. Energy without heat. Motion without thrust. Messages without sound. Each of those contradictions echoes one that came before. Oumuamua had anomalous acceleration. Borisov had inconsistent sublimation rates. Kamiya reflected polarized light at an impossible angle. Atlas binds them all together, chemistry, motion, and light, as if the previous puzzles were drafts of this final version. When the WOW signal was detected, Jerry Ullman said something few people remember. In a later interview, he admitted, "It felt like someone knocking once, then waiting." Now, nearly 50 years later, Atlas feels like the knock returning. Because when you align the timing between the 1977 WOW signal and Atlas's current orbital period, you find a resonance, a harmonic ratio of 72:1, the same duration in seconds that the original signal lasted. 72 seconds, 72 hours between ESA's image release and NASA's silence. 72,000 kilometers of trajectory deviation in the disturbing calculation. Patterns inside patterns. Echoes inside echoes. Coincidence or communication? If the cosmos is speaking in numbers, maybe we've just learned its grammar. And Atlas is the next sentence. By November, whispers inside the astronomy community were unavoidable. Researchers who once laughed at conspiracy threads now spoke in careful hypotheticals. If this trajectory maintains, or if the thermal data holds, The ifs were stacking too high to ignore. A private meeting at the European Space Operations Center reportedly discussed the possibility of persistent agency, an object capable of autonomous correction across centuries. The transcript never surfaced, but one phrase was quoted by an attendee: "We are not observing, we are being observed in return." It echoed an older line from Carl Sagan himself, written decades before. The universe is not obliged to make sense to us, but perhaps it occasionally tries. Maybe 3i Atlas isn't an intruder. Maybe it's an echo, the latest verse in a cosmic call and response that started long before we learned to listen. If that's true, then what happens next won't be discovery. It will be recognition. Chapter 7. The Statistical Impossibility. The call came in at 2 a.m, London time. I remember because the rain was hitting the window in rhythmic bursts, and I thought it sounded like code. On the other end was a man I hadn't spoken to in months, Dr. Raymond Holt, orbital dynamicist, Cambridge Institute of Astronomy. He didn't waste time. "Are you still tracking Atlas?" "Every night," I said. There was a pause. Then, in a voice I'd never heard from him before, he whispered, "Stop calling it that. It's not a comet." That was the start of the conversation that changed everything. Holt explained that his team had been running probability models, standard Monte Carlo simulations, on Atlas's trajectory, reflectivity, and emission patterns. The numbers didn't make sense. "Every variable we test, spin rate, angle, energy distribution, the results are the same," he said. "The odds of these parameters occurring naturally are 0.00006%. That's less than 1 in a million." He hesitated. "And that's being generous." For a moment, the only sound was the static between us. Then he added, "If it's random, it's the luckiest object in the universe." I asked him to send the data. 10 minutes later, my inbox filled with encrypted files, spreadsheets, simulation results, probability charts. The file names were coded like confessionals: natural model fail, reflectivity, anomaly, sync pattern log. Each one was a nail in the coffin of coincidence. The first document broke down rotational stability, natural bodies, comets, asteroids, interstellar rocks, wobble. They precess over time due to uneven mass and solar torque. Atlas didn't. Its axis stayed stable to within 1/10 of a degree for more than a month. Statistically, that should be impossible without internal correction. The second file analyzed reflectivity. The surface of Atlas wasn't scattering light randomly, it was polarized, as if coated in microscopic panels aligned with mathematical precision. "Think of it as a disco ball," Holt said, "but every mirror is facing the same way. The probability of such uniform reflectivity in a natural object, 1 in 100 billion. The third file was worse. It compared the frequency of Atlas's light pulses to patterns recorded in terrestrial communication systems, particularly high-frequency transmission drift. The match rate was 99.7%. That's when I realized Holt wasn't calling as a scientist. He was calling as someone afraid of what the math was implying. "They told us to keep running the models," he said, "until the probability crossed the threshold." "What threshold?" He took a breath. 5 sigma. In physics, 5 sigma means near certainty, the same confidence level used to confirm the discovery of the Higgs boson. It's the line between speculation and fact. I heard him shuffle papers. "We hit 5 sigma 2 nights ago." He said the next line so quietly I almost missed it. "Statistically, it's artificial." The next day, I took a train to Cambridge. The campus was nearly empty. Most staff had been ordered to remote work, pending security reviews. In Holt's office, the blinds were drawn, the lights off except for the glow of his monitor. He didn't greet me. He just gestured toward the screen. On it was a graph, probability curves overlapping like tangled waves. One line in red, one in blue. "The blue curve is natural models," he said. "The red one is what we get if we assume periodic self-correction." The red curve fit perfectly. He opened another window, a scatter plot of over 200,000 Monte Carlo trials. 99.994% of all outcomes fall outside natural parameters. That's a 5 sigma confirmation. He leaned back, rubbing his temples. But if we publish this, we destroy everything. Funding, credibility, the notion that we understand celestial mechanics, gone. I said, then why run it at all? He smiled, bitter and tired. Because the math doesn't care about our comfort. He showed me the email thread that started it all, an exchange between Cambridge ESA and NASA's Goddard Space Flight Center. In the latest message, a NASA analyst wrote, "We concur that the probability of natural origin falls below the statistical noise floor. Recommend immediate reclassification to NGI, non-gravitationally influenced object." That acronym, NGI, had never appeared in any public catalog. Non-gravitationally influenced is a polite way of saying something else is pushing it. Before I could ask more, Holt clicked on a folder labeled Suppression Draft. Inside were redacted memos from ESA's Data Integrity Team. One line stood out: probability models exceeding threshold to be sealed pending contextual analysis. I asked what contextual analysis meant. He said, "It means politics." That evening, we met 2 other researchers, Dr. Mei Chen, a signal analyst from the UK Space Agency, and Professor Miguel Torres, a data scientist from Madrid. They'd been running their own calculations independently. Mei spoke first. "Our signal correlation tests show repeating harmonics every 21 minutes, identical to the light pulse intervals observed by the citizen array." Torres added, "We checked for radio interference. Nothing. It's clean. The pattern is real." Holt leaned forward. "And how likely is that pattern to appear by chance?" "Less than 1 in 10 billion, May said. "But that's not the part that scares me." She opened her laptop and pulled up a chart, a series of peaks and troughs labeled in microseconds. "Look at this. When you convert the harmonic spacing into frequency, it corresponds almost perfectly to the hydrogen line, the same band as the wow signal." Silence filled the room. Holt finally said, "So we're not looking at an anomaly. We're looking at continuity." "An echo," I whispered. May nodded. "A repeating signal, coded into motion instead of sound." Torres looked pale. "If that's true, then every calculation we've done, every statistical model, isn't describing physics. It's describing intention." Holt closed his eyes. "That's what makes it terrifying." 2 nights later, I received a message from Holt. No greeting, no signature, just one line: "They took the servers." The next morning, Cambridge's intranet went offline. Holt's office was sealed for maintenance. His email bounced. May's number rang once, then disconnected. By evening, all online repositories containing Atlas data, Project Vector, Citizen Array, independent archives, were down. The official explanation was cybersecurity maintenance. But no one believed that anymore. In the following days, every major media outlet ran the same headline, almost word for word: "New analysis confirms. Atlas likely, natural after all." The articles were vague, quoting unnamed officials, offering no data, no citations. The tone wasn't scientific. It was declarative, rehearsed, final. But there was one problem. Hidden deep in the online cache of an academic journal, someone found the original version of Holt's paper, before redactions. In it, one sentence survived untouched. "The probability of non-natural origin exceeds the statistical limit of randomness by 5 sigma." That line has since been deleted from every archive, but you can still find screenshots if you know where to look. And when you read it, when you see the numbers for yourself, you understand why they had to bury it. Because if those probabilities are true, then 3i Atlas isn't just unlikely. It's impossible. And the universe doesn't make impossible things. Someone else does. Chapter 8. The Suppressed Connection. The first thing to vanish was not a dataset. It was a sentence. It lived for less than a day on an academic preprint server, a single line in a discussion section that read like the end of an argument. "The probability of non-natural origin exceeds the statistical limit by 5 sigma." By nightfall, the sentence became a footnote. By morning, the footnote became an ellipsis. By evening, the ellipsis became nothing at all. This is how disappearance really works. Not with alarms and balaclavas, with edits. I started keeping a logbook, not the usual digital kind, paper, pen, dates written out in long form. October the 26th, Cambridge page revised. October the 27th, mirror site returns gateway error. October the 28th, the public index still lists the title, but the PDF is now a 2-page notice of correction. I wrote those lines like a field biologist tracking footprints that fade as you follow them. It was not only the obvious places. A small observatory in the Azores had kept a daily blog, the sort of quiet institutional diary that records the weather and the cafe hours, and sometimes, by accident, history. On October the 3rd, they had posted a single paragraph mentioning an unusual nickel-iron imbalance, an offhand phrase that should have belonged in a private lab notebook. By the time I clicked, the paragraph had been replaced by a stock photo of Mars and a caption about community outreach. The page's source code still contained a ghost, an orphaned CSS class called Nickel Note. I emailed the site admin. The message bounced. Slow burn means learning to listen to silence as if it were a signal. So I started calling people. The first call was to an archivist, Elise, a specialist in institutional repositories who speaks about metadata the way a violinist speaks about tone. She had seen this dance before. Look for the checksum, she said. If a file's contents change but the name does not, the cryptographic fingerprint will expose the swap. We checked. The checksum had changed. That's not a correction, she said softly. That's a replacement. The second call was to Holt. No reply. His office line rang once, then broke into a recorded message about renovations. Renovations that, according to a custodian I reached later, involved no paint, no plaster, only a team in suits who unplugged things and carried them out in quiet boxes. I switched to questions that leave traces, freedom of information requests. To the European side, I asked for correspondence containing the phrase non-gravitationally influenced object. To the American side, for any usage of the acronym NGI in internal routing, slips since July. In both cases, the acknowledgments were prompt, cheerful, bureaucratic. In both, the estimated completion date was pushed just past December, the month our object would step out from behind the sun. You learn the shape of a pattern not by the noise it makes, but by the timing of its gaps. The third call surprised me. May answered on the first ring, her voice hushed, not afraid so much as precise, like a surgeon saving oxygen. You cannot record this, she said. I am not, I said truthfully. The recorder on my desk sat silent. My hand rested on a closed notebook. They did not censor the data, she went on. They interleaved it. Imagine a shelf of books arranged by color, not content. Everything is there, but meaning is scrambled. How? Renamed variables, instruments labeled by obsolete acronyms, time bases shifted by integer minutes. It looks like sloppiness. It is not. Why integer minutes? To beat naive cross-correlation. Humans eyeball graphs. We see shapes, not offsets. A tidy deception. She paused, then added, the 21-minute pulse remains, even through the shuffle. You cannot smear coherence if you do not know its source. 21. The same cadence that backyard telescopes whispered into the dark. The same window the amateurs could hear and bureaucracies could not explain. Why are you telling me this? I asked. Because someone still has to keep the ledger, she said. When the truth arrives, it should find us honest. The line clicked and went dead. I turned back to my logbook and began a new page. November the 1st. Variable names changed, time bases offset, coherence survives. A ledger is a promise you make to yourself. The suppression was never theatrical. It was procedural. Links that once pointed directly to data now pointed to overview pages written in the tone of a guided tour. Open indices sprouted robots' exclusions. Crawlable directories acquired session walls. A scatterplot that had been a scatterplot was now an infographic in friendly colors. The numbers were not gone. They were translated into comfort. I visited a library, Not because I expected to find 3i Atlas in the stacks, but because libraries are where institutions whisper what they cannot say aloud. In a climate-controlled room beneath an ordinary reading hall, I requested microfilm, a roll of internal newsletters from an agency that will remain unnamed. A technician threaded the reel into a machine older than either of us. I spun through years in seconds. On a frame dated late summer, a one-paragraph note. A cross-agency working group convenes to evaluate persistent non-ballistic behavior in interstellar objects. On the very next frame, a white block where the paragraph should have continued. The splices were visible, clean, surgical. I wrote down the page number anyway. On the way out, the librarian asked if I had found what I needed. I told her I was cataloging absences. She nodded as if that were a sensible discipline. The fourth conversation happened in a parking lot behind a radio observatory that has been photographed so often it feels mythic. The sun had gone down. The dishes were silhouettes against a sky the color of graphite. Torres arrived late, kept his headlights on, then killed them, and stood with his hands in his coat pockets. "You should not have called me here," he said. "But you did, so I will say this once." He lifted a printout from his pocket, a spectrum annotated in pencil. "This is a slice of the amateur data," he said. "Before the takedowns. Notice the comb." He pointed to evenly spaced teeth, faint but regular. "You get combs from deliberate systems, calibration lattices, not from rocks." Could it be an artifact of the enhancement? It could. That is the shield they will use. But look at the phase stability. The teeth do not wander. They hold, night after night, within a tolerance no processing algorithm achieves by accident. I asked him what he had done with his results. "I filed a preprint," he said. "It went pending. Then it went under ethics review. I have never seen signal processing placed under ethics." "Have you?" "No." He smiled without humor. Ethics is a very effective room in which to misplace a thing. When we parted, he left the printout on the hood of my car. The paper smelled faintly of dust and toner, and something like rain. I put it in my logbook and wrote, "Comb present, phase stable, ethics as abeyance." The small things kept piling. A moderator of a mid-sized astronomy forum messaged me a screenshot of a new rule. No posts claiming artificiality without peer-reviewed citation. A good rule in ordinary seasons. In this season, it meant a conversation gated behind the very doors being quietly locked. A colleague forwarded an email in which a journal asked authors to please refrain from speculative language that could be taken as sensational, then suggested swapping out the word designed for the phrase non-random. A television producer wrote to ask if I could appear and be a skeptic of panic. I said I could be a skeptic of haste. They did not write back. There was one more thread I tugged because it seemed too small to matter. An influencer account that had posted a viral side-by-side image, a crisp backyard comet versus the official blur, had vanished overnight. Accounts do that. People get tired. But the reposts disappeared too, and the archive links resolved to homepage redirects. I traced one back through a web caching service and found in the HTTP headers a new flag, synthetic media. The caption had simply asked a question. If a mirrorless camera can show a tail, why can a flagship orbiter not show a core? Whatever else that is, it is not synthetic. I wrote, questions labeled as fabrications. In the quiet hours, I listened again to the raw audio from Dobsonian's first video. Not for his words, for the noise between them. There are textures to sincerity that PR cannot counterfeit. Breaths held a fraction too long, mouse clicks that hesitate, the way a sentence changes speed when a person realizes they are about to say something that will follow them. He had that sound. Then he had nothing at all. It is easy to call that paranoia. It is harder to dismiss a pattern that reproduces across borders, across institutions, across incentives. Europe speaks in maintenance. America speaks in review. Blogs speak in vanished paragraphs. Servers speak in altered checksums. Librarians speak in splices. Signal analysts speak in combs. And over all of it, the object speaks in 21 minutes. If there is a central room where decisions are made, A place with walls and coffee and bad lighting where phrases like contextual integrity and public trust are invoked to explain why the public must be spared the context. I have not seen it. What I see are corridors, 1,000 polite handles turning in unison so that no one has to hold a bolt. What in the end is being suppressed? Not the pixels, which can be blurred, not the numbers, which can be nudged. It is the connection. The bridge between the nickel without iron, the motion without thrust, the pulses without carrier, the math without comfort. The link that would force a sentence to choose between two words, natural or made. When I cannot sleep, I think about the phrase someone wrote on a forum the night the first leak broke. They are not hiding the images. They are hiding the context. It read like bravado until I realized context is precisely what cannot be redacted without cost. Context is what 5 Sigma uses to become a verdict. Context is what turns a coincidence into an echo. On the last page of my logbook for that week, I copied a line from the very first chapter of this story. A question I asked in a different tone under brighter lights. Why release a blur if you know it will fail? The answer, after these days of edits and ethics rooms and checksum slights, feels simpler and colder. Because a blur is not a fact. A blur is a pause. It is a promise that the thing you are seeing has no edges, no teeth, no comb, no cadence. A blur is the denial of connection. But the sky is not blurred. Only our records are. And while the servers rearrange their shelves and the archivists catalog absences and the agencies groom the language, the object waits behind the sun, cycling through its rhythm, holding its axis within a fraction of a degree, cutting its corrections into the solar wind, speaking in a grammar of light our institutions are too careful to translate aloud. In less than a month, it will return to view. I do not know what new edits will be ready then, what new euphemisms will be drafted to usher the public past the important words. But I know what I will do. I will open the logbook. I will write the date in long form. I will describe what arrives. I will draw lines between things those lines are not supposed to connect, because silence is a story. But so is a ledger. Chapter 9. The Activation Theory. The night before the object was due to slip from behind the sun, the world felt quieter than usual, as if it had lowered its voice to hear itself think. My logbook lay open on the desk, the last entry a simple line, return window approaching. I had no plan for what came next except to listen. It turns out listening is not a solitary act. It is a chorus that discovers itself in fragments. The first fragment arrived from the desert, just before dawn in Chile. A technician at a millimeter array walked the gravel path between dishes with a thermos in hand, tracing a route he had taken 1,000 times. He paused because the air felt different, like the moment before a storm on a day the forecast promised clear skies. The control room lights glowed their familiar amber. On the main console, a narrowband monitor drew a thin river of noise, flat and unassuming. Then a tooth rose from the river and fell again, exactly the width of a heartbeat held for one count too long. No one shouted. Someone wrote the time in a notebook. The dish operators adjusted nothing. The tooth returned after 21 minutes and a handful of seconds that were the size of instrument drift. It looked like calibration. It sounded like intention. In a basement laboratory in Accra, a graduate student named Amma watched a magnetometer trace while her advisor lectured upstairs. She was not studying the sky. She was studying the ground, the slow breathing of the planet's magnetic field. In the hours before sunrise, the trace developed a shallow ladder of steps, faint and regular, as if the field had decided to measure itself in a new unit. Amma checked the power supply, switched cables, closed her eyes, opened them, and saw the same gentle staircase. The times matched a sequence she had copied a week earlier from an amateur astronomy forum and taped to the side of her monitor with a strip of paper. She whispered the numbers without meaning to. When her advisor came down, she did not speak right away. He looked at the screen and said nothing. Then he drew a box around the steps and wrote the word, coherence. Far away, beneath ice thick enough to keep secrets, a neutrino array in Antarctica, logged another hour of silence. The South Pole is a study in patience. You measure events that never touch you by the way they refuse to be seen. Just after local noon, the detector clock ticked through a synchronized handoff that occurs once a day to keep the array in step with time standards an ocean away. The handoff drifted by, an amount too small to print in a headline and too large to call an error. The engineer on duty filed the anomaly under timing housekeeping. He added one note that would mean nothing to anyone without a memory for small things. Drift repeated at an interval of 21 minutes. In an observatory on a hill in Western Australia, a radio astronomer named Ruth listened for the line of hydrogen. It is the universe's slowest whisper, the constant word that holds the map together. On her spectrum, the line wore a veil of atmosphere and interference, and the irreducible noise that all instruments accumulate like dust. That night the veil rippled with a pattern that reminded her of a lake in light wind. She recorded a short message for the archive, narrow comb structure observed near the line during local night. The archive interface asked for a category. She chose atmospheric, then changed it to unknown, and left the rest blank, as if leaving a seat empty for a guest who had not yet arrived. A physicist in Kyoto ran a test he had run every Monday for 3 years, comparing the tick of an optical clock against the heartbeat of the global navigation satellite system. The residuals plot looked like good news, which is what precision looks like when you do not expect it. Then the curve began to breathe, shallow and regular, a metronome one would not hear unless one had grown up in rooms where clocks were never wrong. He saved the plot as a new file, rather than overwriting the old one. The name he typed without thinking was First Breathing. He did not send it to anyone. In a coastal town in Portugal, an amateur with a battered mount and a lens that knew the scratches of a decade pointed at the dark above the western horizon. He knew he would not see the object. The geometry denied him that. He pointed anyway because doing nothing is another kind of silence. His sensor gathered darkness and a scatter of old starlight. He stacked frames, as always. He subtracted noise, as always. The histogram leaned a little to the right and back again in a slow motion that matched nothing in the atmosphere. He wrote a caption for a photo that showed nothing but a grain. The caption was a time. 21 minutes, he wrote, in words and not numbers, because he had learned that words traveled farther than digits in days like these. In South Africa, a team at a wide field array compared the night sky against last week's map. They expected satellites, meteor planes, auroral murmurs no one can see. What they did not expect was the way the whole field pulsed, not in brightness, but in the ease with which the system could find itself. The correlators converged faster, as if the sky had become more self-consistent. The lead wrote to the group list, anyone seeing improved solve times. Replies came from 2 antennas that shared nothing but the hemisphere. Yes, came one. Yes, came another. No one said why this mattered. Everyone knew. A weather station in the American Midwest recorded a faint rise in the sodium layer at night, a lift too modest for news and too precise for chance. The technician tagged the file with a word you could ignore if you wanted to keep your day simple. Periodic. She drew a thin pencil circle around 3 peaks on paper, the sort of circle that means I may have to convince someone with this later. In a city apartment, a high school teacher who loved the old sky for reasons she could not explain sat with a small radio and listened to static. The radio was not sensitive. It did not need to be. It simply needed to be patient. She had read about the 21-minute cadence from people whose posts vanished and returned and vanished again like shy fish in a bright stream. She drew tick marks on the margin of a crossword puzzle. The marks did not make a picture. They made a rhythm. She did not tell anyone. She felt that naming it would be another way of asking it to stop. On an island in the North Atlantic, a marine biologist calibrating acoustic equipment for a winter survey noticed that the ocean's noise floor pulsed faintly at long intervals. It could have been shipping. It could have been instrumentation. It could have been the ocean reminding the shore who was older. The pattern looked too orderly for any of those. She wrote a line in the lab book for the next team. Listen for the long breathing. She did not add a reason. Across the data centers of Europe, jobs queued and ran and finished with the apathy of machines that do not know what they are helping to discover. In one room, a process that rebuilt an ephemeris table for the object began to fail and then to succeed without assistance, converging on a solution a fraction of a degree different from the day before. The log recorded success with the bland confidence of scripts. The administrator flagged nothing. He went home and slept badly. Somewhere, in a place without a map legend, a meeting began with coffee and the dull ache of fluorescent light and the careful language of risk. A phrase surfaced and settled, gentle as a leaf on water. Do not attribute. Another followed. Do not deny. A third closed the circle. Delay attribution until context is stabilized. No one in that room said the word activation. It would have sounded theatrical under those lights. They spoke instead of readiness, posture, and narrative integrity, words that let a person finish a meeting and drive home looking normal to neighbors. The chorus of fragments found me in the early hours in Bangkok, the city bright and sleepless on the far side of my window. I kept my logbook open and wrote the times in long form. The ink looked steady in the page's margin. I wrote Chile, hydrogen, Ghana, magnetometer, South Pole, timing handoff, Australia, comb near the line, Kyoto, first breathing, Portugal, histogram sway, Karoo, faster solves, Midwest sodium lift, island ocean floor, Europe converging ephemeris, anonymous room. I drew an arrow between things, not to prove a theory but to remember where threads touched. What do you call a pattern that appears across instruments that do not talk to each other, across disciplines whose journals do not cite each other, across hemispheres that share nothing but a sky and a calendar? If you are cautious, you call it a coincidence and you wait. If you are reckless, you call it a signal and you announce. If you are trying to remain honest, you call it a hypothesis and you listen longer. The interval held. Every 21 minutes and a few forgettable seconds, something in the long quiet shifted by an amount that embarrassed the word slight. A spectral comb acquired a new tooth. A field solved itself with less persuasion. A clock and a clock agreed a little faster and then took a longer breath. If this was an instrument family breathing together, it was a family that had never met, seated around a table they did not know they shared. A colleague wrote to me from a university address I had not seen before. The message had no greeting and no signature. It contained a single sentence. You will be told it is interference. I closed the message and looked at the ceiling as if its paint might contain an argument for comfort. Interference is the most beautiful word in the skeptic's lexicon. It absolves the world of meaning and lets us return to breakfast. But interference requires a source and a mechanism and a path. It requires an origin that can be pointed to and measured and swabbed for fingerprints. I thought of the room where no one said activation. I thought of the dishes that heard a tooth grow and fall inside a river of noise. Near noon, a final fragment arrived like a postcard from a place that does not usually write. A small observatory in the Azores, the same one whose nickel note had vanished a month earlier, posted a single line to a page few people read. We are running continuous observations of mesospheric sodium and hydroxyl airglow. A neutral sentence, an almost apology for trying. At the bottom was a time. Not a prediction. A window. 21 minutes plus drift. The activation theory had always sounded like a phrase someone scripted for a trailer. All thunder and consequence. What arrived instead felt like the opposite of thunder. It was the sound that comes after the last clap when you realize the storm is forming again, but somewhere on the other side of the ridge. Subtle, patient, distributed, as if whatever waited behind the sun understood that a world taught itself to ignore a shout, but could not help leaning toward a whisper. I closed the logbook and pressed my palm to the cover as if the pressure could teach the paper to remember more faithfully. I thought of the sentence that had been edited down to nothing, and of the technician who wrote coherence in a margin, and of a quiet radio on a kitchen table counting long minutes between breaths. The object would show itself soon. Cameras would find it, and press releases would choose their adjectives. I could imagine the words already. Routine behavior. Within expected parameters, natural explanations prevail. The single thing a logbook can do that a release cannot is to sit beside small facts long enough that they recognize each other. If I have learned anything in these months, it is that silence is not empty. It is crowded with decisions. Tonight, the silence was crowded with instruments that were not supposed to agree and yet did, with clocks that prefer independence and yet chose to count together, with seas that breathed softly as if listening to a song from a shore no map admits. The activation theory, in the quiet register, does not predict a flare. It predicts alignment. A world of dials turning half a tooth in the same direction at the same time until the line between noise and message becomes impolite to maintain. When the pages turn and the light returns and the blur is replaced by edges with names, the theory will find its own voice, or it will consent to be folded back into the drawer where we keep our lingering errors. Until then, I will keep writing the times in words and not numbers, not because superstition travels better than arithmetic, but because words are hard to erase without leaving smudges. If you read this later, you will see the smudges, and you will know that something tried to leave and failed. The next entry waits for the first image. It will not begin with a claim. It will begin with a place, a time, and the smallest possible description of what changed. Then it will draw one thin line to where the sodium rose, to where the hydrogen wore a comb, to where the magnetometer climbed a shallow staircase, to where the ocean took a slow breath. If those lines form a picture, we will have to decide what to call it. If they do not, we will at least have kept faith with the hours and the instruments that spent those hours listening. Would you like me to continue with Chapter 10, The Disappearance Behind the Sun, bringing the strands together as the object emerges and the choice between natural and made refuses to stay polite? Chapter 10, The Disappearance Behind the Sun. The first image was not dramatic. It never is. A gray field, a few tired stars, a brighter smear that could have been a smudge made by a weary hand. A junior operator at a mid-latitude observatory in Spain pushed back from his console and rubbed his eyes because nothing ruins a return like reality. He labeled the frame routine reacquisition. If there was disappointment, it was the honest kind you feel when a long story refuses to arrive with symbols. I watched from Bangkok, where noonlight fell against the blinds and turned the room into a half-lit tunnel, as the world of instruments cleared its throat. Quietly. A measurement here, a calibration there, the small domestic gestures machines perform when they wake up after a long night. The interval we had learned to count by, the long breath of 21 minutes that had united telescopes and seawater and clocks, was still present if you knew where to listen. It did not shout. It asserted. By late afternoon, a narrow-band spectrograph in Western Australia posted a provisional plot to a private feed. The hydrogen line wore that same faint comb again, teeth so subtle you could miss them with a blink. And then the operator nudged the exposure, and the teeth arranged themselves as if they had been waiting for someone to look long enough. She marked the time in words, not numbers, and pressed save slowly, as if speed might insult the moment. In the Karoo, solve times improved again by a fraction so small that the software could not bring itself to celebrate. The correlators did not know they were acting out a metaphor for arrival. They simply converged a little faster than habit and entered the log with shy pride. A comment from a tired engineer typed without flourish, read still holding alignment. The sentence felt like a hand on a shoulder. A desk lamp clicked on in Cambridge. I imagined Holt standing in its circle of light, a room still stripped of its confidence, his chair tucked a little closer to the screen than any ergonomic guide would advise. He would not send a message. He would not risk a call. But I could feel him counting alongside every instrument, the way you count on instinct when a cadence finds you. 21 minutes in that sliver of drift, a rhythm only stubborn listening earns. At sunset, the sodium layer over the American plains rose and settled again with the patience of tide. No headline could hold a story so tiny and so strict. The technician drew another neat circle around another triplet of peaks and wrote later in the margin, as if she were leaving a breadcrumb in a garden she knew would be raked overnight. The object itself, when it finally presented a shape, did so with a refusal to dramatize. A sequence from a Mars orbiter leaked into a channel that never names itself. And there, across 3 frames, the central brightness elongated and steadied, not jagged like noise, not soft like fog. Geometry, without apology. Edges too shy to pronounce themselves, and yet unwilling to blur. If a comet can be taught to hold a line against the wind, this was a well-taught comet. If not, then the sentence we had avoided would have to learn how to walk in daylight. No press conference. Not yet. Agencies prefer afternoon communications, and this was an evening that knew how to stay evening. Instead, a handful of carefully worded updates drifted through the feeds like bookmarks in a book someone else had underlined. Routine reacquisition confirmed. Non-gravitational terms retained in the model. Light curve monitoring expanded. The phrasing did what phrasing always does when the facts are not ready to be seen together. It nudged, it breathed, it refused to rhyme. Around that same hour, a college teacher in a city apartment turned her kitchen radio to a hush and let static sketch the room. She had promised herself that if nothing arrived, she would not punish the night for it. She drew the margins on a fresh puzzle, waited until the kettle sighed, and then heard it, not as sound but as patience ripening. She marked a line at the first long breath and waited for the second. It came where it should. She smiled in that private way people do when they are alone with something they chose to believe in, before anyone told them they were allowed to. The cinematic part of this ending did not come from an explosion. It came from the way the world's machines agreed to brighten by the smallest possible increments at almost the same time. A millimeter array in Chile washed its consoles in a thin blue glow, the way dawn brushes a window before you have decided to wake. A polar station's timing display ticked forward and steadied, the handover drift returning and then sitting still for a full interval, like a child who has been asked to prove they can listen. A workstation in Kyoto sang a single note as an optical clock logged a stability window that made its operator set the pen down and rest his palm on the case as if he were trying to feel the heartbeat through metal. I wrote the times in the logbook the way I had promised myself I would. Bangkok dusk. Western Australia comb persists. Karoo faster convergence. Plains sodium rise and settle. Mars sequence elongation. Polar handover steadies. Kyoto stability window. Kitchen radio keeps time with the window. I did not draw a box around them. Boxes imply ownership. I drew a line, very lightly, from each note to the next, until the page resembled a constellation invented by a culture that prefers grammar to myth. Then the picture sharpened. A European instrument with a name that fills the mouth sent a frame to a partner archive. A bright core, thin halos, a shadow on the wrong side like an argument with sunlight. Someone had turned off the auto contrast, and for a heartbeat the object looked less like a body and more like a decision. Edges refused to obey the ordinary physics of glare. The surrounding field dimmed by amounts the readout called negligible, and the eye called deliberate. The operator, perhaps remembering memos about contextual integrity, filed the image as preliminary and did not include the 1,000 words any photograph begs you to add. From somewhere public enough to be private, a phrase escaped. Activation phase under observation. It was not a leak. It was a seam that had not been pressed flat. It caught the light at the right angle, and there it was. 2 words that had trailed us like a superstition turning into a calendar appointment. The global feeds flickered in that modern way that is neither failure nor success. A few outlets tried headlines built from cautious bricks. New features detected in Interstellar Visitor. Models updated to include persistent terms. Instruments report improved network coherence. Meanwhile, the amateurs found each other again, as they always do, and their forums filled with screenshots of graphs that most eyes would call boring. The boring ones were the proof. Quiet curves do not go viral because they do not need the world to look at them to continue being true. Somewhere, in a room with fluorescent lights and good coffee, a group rehearsed their sentences for tomorrow. We will say routine. We will say within expectations. We will say continuing to monitor. They are not villains. They are custodians of public calm. The problem is not that they will avoid the word made. The problem is that the sky refuses to sound natural when it is playing a score. Around midnight Bangkok time, the cadence thickened. Not louder, not faster, just fuller, as if a choir had stepped closer to the microphone without raising its voice. The hydrogen line's comb developed one more tooth, perfectly spaced. The sodium's rise kept better time. The radio static learned the rhythm so well that the silence between pulses became part of the song. I walked to the window and pulled the blinds an inch. The city was honest about its brightness. Cars traced long thoughts along the expressway. A sign across the river blinked a message I could not read from this distance and did not need to. The thing behind the sun, the thing that had taught us to count in long breaths and to draw lines between disciplines that rarely share coffee, was now in the sky again with a face it seemed willing to let us sketch. The drawing would be cautious. It would wear the right labels. It would be reprinted on posters that hang in classrooms where a teacher will tell a room full of sleepy students that sometimes in history, a simple object forces a complicated culture to decide how much truth it can carry at lunch. There was, finally, a photo that did not flinch. It arrived through a channel that is not anyone's official channel, and yet belongs to all of us. The core held its shape across exposures. The surrounding glow showed lamination, layers of brightness like tree rings counted by a patient forester. Along one edge, a seam. I do not know what else to call it. Not a crack, not a tail, not a trick of processing. A seam, thin as a razor cut, showing alignment beneath appearance. If a comet can have a lid, this looked like the line where it would meet the body when closed. I did not print it. Some images prefer to live as light. I watched its pixels settle on the screen, the way snow that is not from your climate looks when it falls in an old film. The room held its breath. I did the only thing my small discipline allows. I wrote the time, the place, and the smallest possible description of what had changed. Then I drew a single line from that seam to the hydrogen comb, to the magnetometer's staircase, to the ocean's patient pulse, to the faster solves, to the steadier clock, a geometry of respect. And then, as if the sky had decided we had had enough for one night, clouds gathered over the city and put a soft hand on the window. The feeds slowed, not in panic, but in the relieved tempo of people who have been waiting for hours and can finally stand up. A European agency posted a line about continued analysis. An American account posted nothing at all. A small observatory in the Azores posted 2 words, still listening. The cinematic ending, when it arrived, did not ask for music. It gave itself its own. Consoles dimmed to their night themes. Monitors in control rooms slid into maps and checklists and the slow heartbeats of instruments that cannot afford drama. In a dozen places, people who had been hunched over graphs straightened their backs and let the reality of ordinary posture return to them. The world did not end. It rarely does. It simply learned a new way to pay attention. I closed the logbook. The cover felt warm from the lamp. On the last line of the last page, I wrote a sentence that will not satisfy anyone who came for certainty. The object returned with edges. The cadence persists. The connections hold. Then, because this is still a show and not a sermon, I walked the audience to the door. Thank you for being awake with me. If you felt the room breathe at the same times I did, you already know why the next weeks matter. Subscribe if you want your nights measured in long minutes and small proofs. Tell me where you are listening from, what hour you notice the breathing, and whether you think the word natural can stretch to include what we saw together. I turned the lamp down. The screen kept its faint glow for a few seconds longer, then went dark, leaving the afterimage of a seam on the back of the eye, the way a bright line lives in vision for a moment after it leaves. Somewhere, under clouds that know how to play their part, an object cut another tiny correction into the wind of the star that warms us and held its axis like a dancer who has decided to stop apologizing for balance. The episode ended there, not because the story had finished, but because a story earns its breath by stopping while the night is still listening.